We're going to be discussing first Chebyshev's theorem and then a box and whisker plot. For Chebyshev's theorem, it tells me the number of values that should occur within a given number of standard deviations from the mean. So let's start out by taking a look at the formula. It's 1 minus 1 divided by k squared. Now k is the number of standard deviations from the mean, and k has to be greater than 1. When we say standard deviations from the mean, we mean number of standard deviations to the left of the mean and to the right of the mean. For example, if the mean was 5 and the standard deviation was 2, one standard deviation would be from 3 to 7. So if we looked at the number 5, standard deviation 2, we would have to do something like 5 plus 2 and 5 minus 2 to find out my values that were one standard deviation to the left and one to the right. So one standard deviation to the left would have been 3, and one standard deviation to the right would have been 7. What about if I had two standard deviations out? Well, two standard deviations out would be 2 times 2, which is 4, because that's two standard deviations out. Then I would add 4 to the 5 to get 9, that would be the value to the right, and 4 from 5 to get 1 to be two standard deviations to the left. So from 1 to 9 would be the values represented by two standard deviations from the number 5. Let's calculate how many values there would be two standard deviations out. Well, it's 1 minus 1 divided by two standard deviations squared. Well, two standard deviations squared, you can write it as 2 caret 2. I'm just going to write it as 4. So I have 1 minus 1/4, which is equal to 0.75, which is 75%, which means that 75% of my values should be within two standard deviations of the mean. Sorry about that. Should be within two standard deviations of the mean. Again, that was 1 minus 1 over 2 squared, which is 4, and 1 minus 1/4 is 0.75, which is 75%. Let's move on to a box and whisker plot. The box and whisker plot is based on breaking your values up into things called quartiles, which represents 25% of your data set. We're going to take a look at this by first having sets of data and talk about how to find a box and whisker plot. In a box and whisker plot, we're going to have these values called quartiles as Q1, Q2, Q3. Now, Q2 is going to be the median of my original set. Q1 and Q2 are going to be the medians of the subsets that are created. The minimum and maximum values of the quartiles are plotted on a number line. So we're going to construct a box and whisker plot for this set of data values right here. Keep in mind, in order to find the median, or calculate it in some cases, I need to have these numbers in sequential order. So that's what we'll begin with. What I've done is I've organized this first data set. These are two separate problems, so I'm doing this one first, into 11 values. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 values that are now in sequential order. To find the median, I find the middlemost value. That'd be 1, 2, 3, 4, 5, 6. The number 5 right here is going to be my median value, because if I have 11 values, I now have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So my median right here is 5, and that's represented by Q2. Okay, so I know that 5 is going to be that first value. Now we're going to find the median of this. Well, there's 1, 2, 3, 4, 5 values. So the number 2 is going to be the median of that data set. And on the right, we have 5 values, 1, 2, 3, 4, 5. And so my median there is going to be 8. So I went about circling each of my medians. So the median, as we mentioned here, was going to be my Q2. So I've identified my 3 quartiles. Q1 was the median of my first data set. Q2 is the median of the entire data set. Q3 was the median of my third data set. And I have all my values set up again. So just let's look one more time. 5 was the middlemost value because there was 11 values, leaving 5 to the left and 5 to the right. Of the remaining 5 to the left, 2 is the the median, because it leaves 2 values to the left and 2 values to the right. And the like argument for the number 8. So I have my 3 quartiles. Now I'm going to go about plotting this, and I'm told to use a number line. And I have to get a number line that goes from 1 to 10. I apologize, I misspoke. I should have said 0 to 10. So I'm going to identify my quartiles first. Here's my first quartile. Draw a line right through it, and that'll be my Q2. That'll be my Q1 at the number 2, and then my Q2 is at the number 5. I'm going to draw that one a little larger, and I'm going to go over to Q3, which is at the number 8. And at the ends, I'm going to put dots. I'll put a dot at 0 and a dot at 10. That was my minimum, my maximum value. I'm going to complete my box and whisker. Just drawing my lines over and drawing in that line with a dot at the end and that line with a dot at the end. This is to break up my values so that each of these sections is 25%. So if this is 25%, this is 25%, this is 25%, this is 25%. I want to find the inner quartile range, which is found by doing Q3 minus Q1. Well, in this case, Q3 was 8 and Q1 was 2. So 8 minus 2 is 6. So my inner quartile range for these values are 6. It shows me how far out the numbers are spread. I'm going to repeat this with the next data set, and this time I'm going to have an even number of values. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 values. So I have to find the midpoint, the median of these values. So with 10 values, I'll need 5 to the left. 1, 2, 3, 4, 5. So right here is going to be my median. So that's my median for my first data set. And I find that by adding 5 to 5, which is 10, dividing by 2 is still 5. I'll find my value to the left, and there's 1, 2, 3, 4, 5 values. That's my other midpoint. And here I have 1, 2, 3, 4, 5 values, and there's my other midpoint. So I found my 3 midpoints. I'm going to draw out the same kind of number line. The number line is going to be numbered from 0 to 10. My lowest number going up to my highest number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My endpoints are existing at 0 and 10. My first midpoint, my Q2 is found at 5. My Q1 was found at 2. And my Q3 was found at 8. That's my box and whisker plot. 25% of the values are found here, 25% here, 25% here, and 25% here. To find my inner quartile range, I would do Q3, which was 8, and I would subtract 2 from that, and I do 8 minus 2. Whoops, this would right, and I end up with 6.